Alright guys, welcome back. This is a question from Chapter 6 review set 6A, question 8. It's like the ones we've been doing in the chapter, so we shouldn't have too many troubles. Let's see how we go. For what values do the lines with equations y equals 3x plus c intersect the parabola y equals x squared plus x minus 5 in two distinct points? Again, I'm without a stylus here, so you're going to have to persevere with my typing. But I don't think it'll be too bad, and we'll see how we go. So we're going to start this one off, of course, by letting the equations equal each other. How are we going to find where things intersect? They're going to be equal, so the y values will be equal. So I can start with 3x plus c is equal to x squared plus x minus 5. Now I've just got to click on here, get the right formatting. X squared plus x minus 5. Okay, so now we've got to set it equal to 0, so we can go ahead and factorize and solve it. So here I'm going to have, I'll copy that first and then fix it up. So I've subtracted 3x from each side, so the x squared will stay the same. If I have x and I take away 3x, that's now going to be negative 2x in the middle, and the negative 5, I've also got to take away c. So that's what I'm going to end up with. Now remember, we like to have it in the nice ax squared plus bx plus c form, so I'm going to have the same thing here. The first two bits are going to be exactly the same. I've got 1x squared minus 2x. What I'm going to do with this last bit, I'm going to take out that negative 1 as a factor. It's just going to make it a little bit easier for me to deal with. So I'm going to take out the negative, and I'm going to have 5 plus c inside the brackets. Factorize it nicely. Now I know what that last constant term is. Alright. Next bit, two distinct points. What do we know? A parabola is going to give us two answers. Two distinct points. The discriminant is going to be greater than 0, so there'll be two roots. So I should be able to ensure that the discriminant for this one is greater than 0. So let's go ahead and do that now. The discriminant, of course, is b squared minus 4ac, which in this case is negative 2. I didn't insert it as an equation. Let's fix that up. I know what I'll do. Type here for the equation. Get these tools sorted sooner or later. There we go. Pop that into the first bit. Negative 2 squared, so that's b squared, minus 4 by the value of a is 1, and the value of c is 5, negative 5 plus c. Got to remember to include that negative. Simplify this, and we know that this has to be greater than 0 because we want the discriminant to be greater than 0. Let's simplify it and see how we go. Get my equation editor back. It'd be much nicer when I can use the stylus to do these for you just a little bit more quickly. What are we going to have here then? Negative 2 squared is 4. I've got a negative 4 and another negative in the bracket. That's going to combine to make a positive. I'm going to have 4 by 5 is 20, and 4 by c is 4c. So that's all going to be greater than 0. 24 plus 4c greater than 0. Obviously you can probably see the answer already, but let's just keep going anyway. Oh, that didn't put it in the nice, beautifully formatted equation, so I'm going to go back and get that, so it's going to look nice for you. Doesn't look much nicer at all, does it? Let's just persevere. It's getting late. I've got basketball in a few hours, so let's sort this out. 4c will be greater than negative 24. Divide by 4. C c is greater than negative 6. And it says choose one c value from part A and find the points of intersection. Before I go ahead and do that part B though, I want to convince you that you're right. This is something you want to be able to do on your graphics calculator in the exam. I don't have a graphics calculator here, but let's see if we can use Desmos to help us out a little bit. So we'll tab over to Desmos. I've got to remember what I've got to put in here. I've got to put in the first equation, y equals x squared plus x minus 5. So let's do that. Y equals x squared plus x minus 5. It's actually a little bit easier to enter information in here. And the other one was y equals 3x plus c. Y equals 3x plus c. Now remember, Desmos is great because you can add a slider. If you're doing it on your calculator, you just substitute in the value we obtained, which was -6, and you should see that it's a tangent at that point. So if I slide this down to -6, a bit too far, you'll see, yep, that is exactly right. There's a tangent at -6. Now we've claimed there'll be 2 points of intersection if it's greater than -6. So if I go above -6, yep, you can see there are 2 points of intersection all the way through. And I wonder if I can just click on them and get it to show you those changing as I move up and down. What happens at -6? There it is, 1, -3. And if I go below -6, the straight line is going to lie beneath the parabola. We're not going to be able to have any roots, so there'll be no points of intersection. So that's exactly as we expected. We know we've got the first bit right. Let's jump back in and do part B now, and then we'll be able to check it on this parabola again, seeing as though we've already got it set up. So for part B, choose one such value from C that satisfies it and find the points of intersection. I'm going to go and check what value was suggested to me in Edmodo, and we'll be back. Obviously it took me longer to check the value than it did for you to wait for me. So here we go, C equals 75. So this is for part B. I'm just going to, I could let C equal anything. Let C equal 75 and let's solve it. So from there, I've just got to find the points of intersection. So I'm basically solving the same equation that we had there. 0 equals x squared. Now we'll just copy it, that's going to be faster for us. 0 equals x squared, and all I need to do is replace the c with 75. We can make that look a little bit prettier. So next line of working, and look something along the lines of 0 equals x. Remember how to do this, silly man. It's important to have that dialogue going when you're doing your own problems, guys. Keep yourself on task. Keep talking to yourself, remind yourself of the procedures and the processes that you need, and you'll be alright. So x squared minus 2x minus 80. So 5 plus 75 obviously giving us 80. Now, did we choose numbers that would work nicely? Cleverly we did, because what do we see there? Two numbers that multiply to equal -80 and add to equal -2. I'm going to go with -10 and +8. So good choices there. Here I was thinking 75 was a strange choice. It's a well thought out choice. That's good to see. X minus 10, x plus 8 would be the factorization of that one. Therefore, x equals 10 or x equals -8. And to find the points of intersection, I obviously need to find the y coordinates that match up with those. So when x equals when x equals 10, y is going to equal, I'm going to sub it into the first one, that's going to be a lot easier. So when x equals 10 and that's 75, we're going to have 30 plus 75, y is going to be 105. Or when x is -8, that's -24 plus 75, y should equal, I'm going to make that 51. Let's see how we go when we get back over here to Desmos. Where'd you go? There it is. Now we've got to change out, I've got to zoom out a bit here because we've got c equaling 75. Good news about that is I can just type that in there. Ooh, -851, that's one we wanted. What's the other one we said? 10 105. How'd I go with my maths? 10 105, -851. There you have it. Hope that works for you. If you want to try it again with a different number if you had trouble, that's probably a good idea. Cheers.